Yeah, good morning, everybody. Yeah, good morning, Dr. Sabiha. Thank you very much for your time to give the guest lecture for our students, especially for the uh, first year of undergraduate student, because the topic is about the analytical chemistry. Hello.
Yes, I can hear. Yes.
Okay. Before we continue, I would like to, can I share screen? Okay, a little bit about the Dr. Sabiha. So please, Dr. Sabiha, you stop your screen and I will share my screen.
Okay.
Okay. Okay. I will share my screen. This is about the curriculum vitae of Dr. Sabiha. So for the students who haven't acknowledged with Dr. Sabiha, so this is the curriculum vitae of Dr. Sabiha, our guest lecturer today. So Dr. Sabiha Hanim binti Saleh, she's an associate professor and she's a lecturer, well, our associate professor in the School of Chemistry Environment, Faculty of Applied Science, UiTM Shah Alam, Selangor, Malaysia. So you can see her contact number and also the email. Probably if you want to discuss further with Dr. Sabiha, you can contact directly to her probably WhatsApp number. Is it okay, Dr. Sabiha?
It's okay. Yeah.
Okay, or also email. And Dr. Sabiha graduated from Diploma in Science into Teknologi in 1992 and a bachelor in the Universiti Kebangsaan Malaysia UKM in 1996. Master in Environment, University Putra Malaysia, UPM in 1999, and the Doctor of Philosophy in Environmental Health and Waste Management, University Science Malaysia in 2010. And there's so many data of Dr. Sabiha, and I don't want to read because it will time consuming, right?
Yes.
Yeah, she has achieved many achievements in her career, and basically her research is about the what is it? Research about this. This is the research about the, for example, like the alkinate incorporate multi-wall carbon nanotube as dispersive micro, and for the study on the formation of PVA canal nanofibers via electrospinning. So it's mainly about the, what's it about what? Dr. Sabiha.
Heavy cellulose. I focus by mass.
Oh, biomass.
Yes.
Okay, so biomass. Okay. Here in our university, uh, the researchers who focus on the biomass probably from the chemistry department or chemical engineering department.
Yes. Okay.
I think it's okay. Okay. I think it's all that I can give the CV of Dr. Sabiha. It's about 9 pages, so many achievements. And now it's time for Dr. Sabiha. So I give the opportunity for Dr. Sabiha to conduct this uh, guest lecture. So I will stop my screen share and I will give the opportunity to you. Thank you very much. Please,
Okay.
Dr. Sabiha.
Okay. Thank you, Associate Professor Dr. Diah. Okay, I will share the contents. Okay. Can you see?
Yes, we can see it clearly.
Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Okay. So can I see any students? Any students here?
Yes, many students.
Oh, okay, good. Okay, so if I'm not mistaken, there is 133 participants.
Yes.
Yes.
Yes, okay. So I can start now, right?
Yes, you can start, Dr. Sabiha.
Okay. So the title for today's lecture, I choose volumetric analysis. Okay. So first, for the first hour, I would like to ask the students, anyone know about the volumetric analysis? Any students? I can interact with the student, right?
Yeah, it should be. You can interact with them.
Yes. Okay, anyone? Anyone to tell me, is it you know about what is a volumetrics? Ada siapa-siapa yang tahu? Okay, so it's okay. We will go to and then you will go, right? Okay, what is the volumetrics? Volumetry is actually, we also can call as a metric analysis. Okay, so in this topic, under volumetric analysis, I will discuss, if we have enough time, we will look on the acid is titration. Okay, for the first acid is the second about back titration, the third complex soap metric titration, fourth redox titration. So if we have the enough time, I will cover about the precipitation titration. Okay, so volumetric analysis actually focus more on the titration. More on the titration. Okay, now we look at what is titration. Titration is actually a procedure. We control the addition of the reagent to analyze. So in the titration, we should have the titrant. Beside the titrant, we also have the analyte. So beside the analyte, one more, we should have the indicator. Yes. So to complete the titration process, to complete the titration process, we have the titrant, we have the analyte, and also we must have the indicator. So this is the apparatus. This is the apparatus we use. So we must have the burette, we must have the at least coordinator pass. And then what we put inside the burette? Normally we put inside the burette is the titrant. So what we put inside the elevator plus or conical plus? So inside here is actually analyte. Okay, that is the process, the titration process. So what is analyte? Analyte the unknown solution. So the unknown solution whose concentration is being determined. So meaning that we don't know about the concentration of analyte, but we want to determine the concentration. So how about the titrant? The titrant is actually the standardized solution. So either acid or base. So normally the titrant, we know the concentration, right? Okay. So beside the titration process, there are a few things that we must know. The first about the endpoint. So what is endpoint? The endpoint, the point at which the reaction is observed. So kita observe the reaction to be completed. So when we carry out the titration, we will ask, so when I should stop the titration process? So we have to stop the titration process and we reach the endpoint. So the endpoint in volumetric method of analysis is the signal that tells the analyst to stop adding reagent. Adding reagent meaning that adding the titrant, and then make the final reading on the pipette. After that, after we stop the titration, we have to read. From here, we stop the titration process, so we read from the pipette. Okay, so therefore the endpoint seeks the analyst to stop adding titrant. Okay, the endpoint is observed with the help of a suitable indicator. So because of that, when we perform the titration, we have the endpoint, we have the titrant, so we must add the indicator because endpoint we absorb with the help of the suitable indicator. Okay, beside the endpoint, we look at the equivalence point. So what is the equivalent points? So equivalent point is actually the point at which an equivalent or stoichiometric amount of the titrant added to the endpoint. So meaning that before we reach the endpoint, we must reach the equivalent point first. So the equivalent point is actually the stoichiometric amount of titrant. So the titrant we add to the endpoint, and then when we reach the equivalent point, after that we will reach the endpoint. So theoretically, the equivalent point is actually we can calculate. We can calculate the amount of the titrant that required. Exactly with the amount of endpoint present. So one more term. This is about the title. So what is the title? Title is actually the volume of the titrant required to just completely react with the analyte. So we call the title. So if you can see here, drop by drop, so we will refer as the title. Okay, so is it okay, the students? Up to now?
Okay, ma'am.
Okay, all right. Okay, so and then we proceed to the requirement for a successful titrimetric procedure. So here I use the titrimetric. Actually, we also can use as the volumetric procedure. So to perform the titration, make sure the titration successful. So there are a few requirements. For the first, the reaction must be stoichiometric, meaning that will define reaction between titrant and analyte. Okay, the second, sufficiently stable, so that it is necessary to determine its concentration only once. The third, the reaction should be rapid, rapid with the analyte, so that the time required between the addition of the reagent is minimized. So next, the react completely with the analyte, so that satisfactory endpoint can be achieved. So last, the reaction should have no side reaction. So during the titration process, we have to make sure that we choose the titrant and analyte very compatible each other. And then when we perform the titration should have no side reaction, no interference from other foreign substances. These are few requirements for a successful titrimetric procedure. Okay, so students, if you have any questions, you can interrupt me. Okay, and then we proceed. Okay, we focus kepada acid-base titration. Okay, what is acid-base titration? Acid-base titration is an experimental procedure used to determine the unknown concentration of an acid or base. So this process actually we refer as the neutralization process. So the reaction between acid and also base. Okay, as I mentioned earlier, for the titration we should have the indicator. So in the case of the acid-base indicators, So the function of the acid-base indicator actually by changing color just after the equivalent point. Okay. So indicator in this case I discussed there are two types. Okay. And we call monoprotics. The second one is the diprotics. So mono meaning one H. Diprotic we refer to as a two H. Yeah? Okay, IN refer abbreviation to the indicator. So the acid form and indicator is usually colored. Yes, of course, because if no color, difficult to us to identify the endpoint. So when it loses the proton, it will result in an ion. That is the process. Yeah? From the color A, we will change from the color B to the color B. Okay, so this case is a diprotic acid. Yeah? In this case, a diprotic acid indicator. So here, the atom, the hydrogen atom, we have two. Yeah? So the hydrogen indicator H2ion ionized in two steps. So if the monoprotic only involve one step, because one hydrogen. However, in the case of the acid-base indicator, it will involve two steps. Okay, this one step and this one is another two steps. So the color change from A to B, and the last color is actually C. Okay. So how you want to select the indicator? Yeah? How you want to select the indicator? Selecting and using indicators. So choose indicator that undergo a distinct color change. So distinct color change a very sharp color, and we can differentiate. We can differentiate the color. So the distinct color change at the equivalent points. Okay, the second, choose indicator whose middle half of the pH transition change. Yes. So why? Because then we can get the greatest color change, so it compresses or overlap the pH at the equivalent points. So the third one, for indicator color change to be detectable by normal eyesight. So mana dia apa? We can see. Ya, kita boleh lihat dengan mata kasar. Okay, that is the how we select and using indicators. Okay, choosing a titrant. Okay, in a theory, any strong acid or strong base we can use as a titrant. Okay, the reason for this, the most reaction involve a strong acid and also a strong base. So when it's involved, the acid-base titration normally it fall under category quantitative. Quantitative, we can calculate. We can calculate the concentration, for example. So these are the list, for example, of acid. Okay, beside the list, anyone you want to give extra about the strong acid? Anyone? We have any? Beside this, beside hydrochloric acid, nitric acid, perchloric acid, phosphoric acid, sulfuric acid, selain daripada itu, anyone? You can say yes. Any strong acid? If you know. Anyone yang tahu? Ada siapa-siapa tahu? Selain daripada this I list here, okay, hydrochloric acid, nitric acid, perchloric acid, phosphoric acid, sulfuric acid. Okay, there are other acid. If you want to know, you can check. And can find out. Okay, ada light acid. Okay. So weak acid titrant. This one is a strong acid. Strong acid. Strong acid normally they have H. H plus. For example, here we have 2H plus for the sulfuric acid. For the phosphoric acid, we have 3 plus. Okay. So this we refer to the strong acid. How about the weak acid? Weak acid, example, carboxylic acid. Example, acetic acid. acetic acid. So the different dia ada this one, dia functional group, dia functional group. So weak acid, ammonium, hydrogen chloride, carbonic acid, nitrous acid, hydrogen sulfide, and hydrogen cyanide. So there are more. So I just list of weak acid. Okay, how about the strong base? Strong base. Strong base example, we have sodium hydroxide, we have the potassium hydroxide, magnesium hydroxide, and also cadmium hydroxide. Example strong base, H. So for the base, we have OH. So if the acid, we have the H, H plus. How about the weak base? Weak base, we have the ammonium hydroxide, we have the carbonate, chloride, and also sodium carbonate. These are the example, strong base and also weak base. So to perform the titration, we use acid or we use base. And the titration, either we can react with the strong acid with the strong base, strong acid with the weak base with the strong acid. Sama lah tadi Okay, so kita take note. Okay, when we perform the titration, so what's the titration give the information to us? So first, we can plot the titration curve. From the reaction, we can plot the titration curve. So this titration curve, I give the example where we add the acid. So meaning that acid we put inside the burette. We put inside the burette. So that's why we put here the volume of acid added. So in burette, you can put the acid or you can put the base. It depends what type of the titration. Okay, so the titration is between the strong base with acid. This the curve. So you can see this one we call dia adalah equivalent point. I just short from the EQ. EQ refer to the equivalent point. So just previously I mentioned before the color change, so we must reach to the equivalent point, the process. Okay, for the strong base and weak acid, when we add the acid from the titrant, we add to the end type, the process, so it will give the equivalent point. So if you look the equivalent point, the pH is actually around 8. So why? Because strong base. Okay, so we look the example for the strong base, strong acid. So for the strong base, strong acid, the equivalent point just pH 7. Just pH 7. Okay, so not more than 7 and not less than 7. Okay, so as you know, is less than 7, the condition is acid. More than 7, the condition is a base, base condition. Okay, so how about the weak base? For the weak base, strong acid. Weak base, strong acid. So we focus to the strong acid. The equivalent point is 1, 2, 3, 4, 5, around 5 something. 1, 2, 3, 4, or 4 point something, 4.8. So the equivalent points are less than 7. Because of what? Because of the strong acid. Okay, why? Equivalent point is 8 something. 8 for example, because this is the strong base. That is the strong base. So if the balance strong base, strong acid, the equivalent point at 7. How about the weak base and weak acid? Normally, weak base and weak acid, for the actual procedure, we cannot perform the titration. We cannot perform the titration because very difficult to find the suitable indicator. Because to find the suitable indicator, we must at least this type of stick. If you can see here, this is the stick, at least here we can have. However, for the weight-based, we don't have. So, weight-based and weight acid, we cannot perform. Okay, we don't perform the titration for weight-based and weight acid. Why? Because there is no suitable indicator. Okay, now look at this titration curve. And this titration curve also strong acid and strong base. Strong acid and strong base. So if the student alert, what's the difference here compared to here? This one, for example. Okay, this one, volume of acid added. However, here, volume of base added. So you can see the pattern, the pattern of curve. If the volume of acid added, the curve from the high, and then it becomes the bottom part. However, this from here, they increase to here. However, this one come like this. So that is the difference. The student has to learn the pattern due to the different type of acid or base added. If we add the acid, this is the type of curve. This is type of the acid-base curve. However, if we add the base, this type of curve. Tapi the equilibrium point is exactly same. If the strong acid is strong base, the equilibrium point is equal to 7. So for the strong base and strong acid, the equilibrium point is also 7. It's also 7. Okay, I just show one example, the difference of the titration curve when we add the acid or we add the base. We add the base. That in this case, we add the base. When I say we add the base, the student have to imagine that the base is actually inside the burette. That's for you. Yes. This one, we have the burette. Okay, so here is the titrant. The titrant is actually, this is base. This is base. Okay. We can put here inside this one adalah acid. Acid. So when we add the acid, so here, this one. When we inside the direct base, so we will get this. This one example. So we try to look what the application, why we want to study the acid-base titration. Okay, acid-base titration example, if you want to determine, you want to test the purity, the purity of a high sodium hydrogen carbonate. For example, a sample of sodium hydrogen carbonate was tested for purity using the following method. So the following method, they refer, we have 0.400 gram of the solid sample. And then the solid sample we dissolve in 100 milliliter of water. So the process when we say we dissolve in 100 milliliter, normally dissolve the preparation of the solution, we use the volumetric class. We call this one as the volumetric class. Okay, so we have the 0.4 and we have the volumetric 100 ml and then we dissolve inside here. Okay, after that kita buat apa? And titrate with 0.200 molar hydrochloric acid using metal orange. So I just mentioned about the suitable indicator before. So actually for the some titration, for example, acid base. Actually, what type of indicator we can choose? Normally, we can choose either phenolphthalein or we can choose the methyl orange in our practice, in our lab. Okay, so in this case, we have we have the titrant and we have the indicator. So try to identify which one is the analyte and which one is the titrant. Okay. Anyone, you want to tell me which one is the analyte and which one is the titrant? Okay, any students? It's okay. Anyone? Anyone? I don't know your name, so I can't call your name. Okay, anyone? You just get respond. I just want to know whether you understand. So which one and which one is the titrant? So actually we already have the sodium hydrogen carbonate, and we also have the acid. Acid is hydrochloric acid. So sodium hydrogen carbonate and hydrochloric acid. Which one is analyte? Anyone? No one? No one to answer? Try to answer. Yeah, you try to answer.
Rafael, Ma'am. Rafael Ria.
Okay.
Yeah, Rafael. Ask Rafael to answer.
Okay, what's the answer? Analyte.
Rafael.
Excuse me, ma'am. Can you hear my voice?
Yes.
Is it the titrate, ma'am?
Okay, I just ask yang mana satu adalah analyte, sodium hydrogen carbonate or hydrochloric acid?
Or the analyte, ma'am?
Yes.
It's the, let me see. Is it the sodium, ma'am? The sodium hydrogen carbonate?
Yes, correct. Good. Yes, the analyte is actually sodium hydrogen carbonate. Okay, how about the hydrochloric acid? Hydrochloric acid, titrant, because the hydrochloric acid is actually we put inside the big red. Yeah. Okay. Correct. So when we do the titration, at least you have to identify. So in bahasa Indonesia, maybe identify, we can say kenal pasti. I'm not sure whether the correct word. Yeah. Okay. You can you know yang mana satu analyte and yang mana satu titrant. So in this case, analyte is sodium hydrogen carbonate, and then dikatakan titrate. The word is a titrate, and titrated with 0.200 molar hydrochloric acid. The word titrated, so that is the titrant, right? Okay. So when we know about that, and then we know how to plot the titration curve. Yes, so you must to identify the analyte and titrators. Baru kita boleh buat apa? Baru we can plot the titration. So the first, write the equation. Sodium is actually Na. Kalau bahasa kita call sodium adalah natrium. Natrium. That's why the symbol is Na. Hydrogen, carbonate. Sodium hydrogen carbonate. In what form? In a solid. When we are as a gas, when we write this referred to as the solid. Okay. AQ is the aqueous. Aqueous means liquid. Okay. So, and then is a liquid. It is a liquid small, aqueous, and also this one gas. Yes. Okay. So sometimes they will write the condition of each of the chemical. Yeah? So I would like to focus in the chemical equation. So look at the chemical equation. We have the sodium hydrogen carbonate. We react with the hydrochloric acid. Yeah? Okay. Hydrochloric acid, HCl. Okay. What is the product? Hasil dia apa? Ini we call dia sebagai bahan gas. Yeah? Okay. The reactant. So we have the sodium hydrogen carbonate, react with the hydrochloric acid, and then the product is the sodium chloride. Okay, in this case, acid base. Yeah? So acid base titration tidak balas acid dan juga dengan base. Ya? Tidak balas dia adalah hasil dia adalah garam and water. Water air. Yeah? So the product is actually, we have the acid, and then we have this reaction, we will get the salt. Yeah? This one is the salt. And we have the water. So the normal acid and base is actually production. It will produce salt and water. However, in this case, kita ada gas. Yeah? Gas. This gas ada extra. Yeah? Besides yeah? When your chemical equation complete. Okay, the second question about the titration curve. So the question asks us to sketch and label the titration curve. Okay, so for the titration curve, how you have so why the title is the acid? Because dia kata dekat sini dah titrated with 0.200 molar hydrochloric acid. Okay, that's why we know how to plot the titration curve. If we cannot differentiate the titrant and also the analyte. So you will sketch Rowley titrate. So in this case, acid. So if you still remember this type of, just we have to divide the titration with base, for example. So which one? All the weak acid with the strong base. Okay. So in this case, if you look here, the equilibrium point is less than 7. Yeah? Less than 7. So we can see that this is the strong acid. Strong acid. Acid, and because we have the sodium hydrogen carbonate, this one is the weak base. Ini adalah weak base. So the titration is actually strong acid and weak base. So that we can plot the titration curve. The calculation. This is the calculation. The question asks you to test purity. Purity. Okay, determine the purity of sodium hydrogen.